How are you? This is me, Ataur Rahman, with a new video of grade 12 Mathematics. Unit 1st, Functions and Limits. Dears, before starting functions and limits, let us define some basic definitions. The first definition is the Cartesian product. The Cartesian product of two non-empty sets A and B is denoted by A cross B and is defined as A cross B is a set which contains ordered pairs such that the first component of each ordered pair belongs to the first set and the second component of each ordered pair belongs to the second set. In similar fashion, we can define B cross A. B cross A is also a set containing ordered pairs such that the first components belongs to the first set and the second belongs to the second set. And you see here, B is the first set and A is the second set. Okay, this definition means that the Cartesian product A cross B between two sets A and B is the set of all the possible ordered pairs with the first element X from the first set and the second elements Y from the second set. In general, A cross B is not equal to B cross A. That is, Cartesian product is not commutative. Okay? But there is a particular case in which A cross B is equal to B cross A. When this case happens, when both sets represent the same set, that is A is equal to B. If the number of elements in a set is denoted by N of A or O of A, called order of a set A, or vertical bar of a set A, then the number of elements in A cross B will be the number of elements in A multiplied by the number of elements in B. That is, if we are interested to find the number of elements in a set A and the number of elements in a set B, so we will just multiply their order and we will get the number of ordered pairs in A cross B. Okay, let us have some example on it. This, suppose we have a set A 1 2 3 and B is 4 5. Now set A has 3 elements, that is the order of a set A is 3, the order of a set B is 2. So the number of elements in A cross B will equal to 3 2s are 6. That is, A cross B will equal to, it will contain 6 ordered pairs. And according to definition, these ordered pairs are formed, the first elements belongs to the first set and the second elements belongs to the second. In each ordered pair, we have repeated the definition, that is 2 belongs to the set A while 5 belongs to set B and etc. Similarly, we can define B cross A. The first set belongs to the first set, that is B, and the second elements belongs to the second set, that is A, and etc. So from these two examples, we see that A cross B is not equal to B cross A because their ordered pairs are not the same. Here we have 1 comma 4, while in B cross A we have 4 comma 1, and in the rest as well. So A cross B is not equal to B cross A in general, as already remarked. Now, for example, if we have a set A 1 2 and B is equal to 1, of course these two sets are the same. Why? Because number of elements, the order of elements in the set are not important. So clearly both have the same order. That is, set A has 2 elements, set B has 2 elements. Now the number of elements in A cross B will equal to 2 2s are 4. It will become 4 and A cross B will equal to 1 2 2 2 2 1 and 2 2. Similar B cross A will equal to the same set, that is 2 comma 1. Of course it exists in A cross B. 2 comma 2 it exists there, 1 comma 2 already available, and 1 comma 2 exists there in A cross B. So we see that if both the set represent the same set, then their Cartesian product will be the same. Okay, further moving toward the next definition. The next definition is the binary relation. What is the binary relation? Any subset of the Cartesian product is called binary relation, or simply we call relation. Okay, any subset of the Cartesian product is called binary relation or relation. If the number of elements in a set A is equal to k1 and the number of elements in a set B is equal to k2, then the number of elements in A cross B already discussed will equal to the number of elements in the first set multiplied by the number of elements in the second set. This total binary relation in A cross B will be, now we are interested to find how many binary relation will be there in A cross B. So for that we have the formula that it will be 2 to the power k1 multiplied by k2. That is, it is so simple. To find the number of binary relation in A cross B, we just put the number of elements of set A and the number of elements of set B in exponent of 2 to get the total number of binary relation from A to B. Similarly, if we have a set just A and it has element k, then the number of elements in A cross A will equal to k cross k is equal to k square. Thus total binary relation defined on A will be 2 to the power k square. Of course it is that formula, but here k has the same, that is the first set A has k element and the second set k is also set A is also k element. So the total number of binary relation in A cross A will be 2 to the power k square. Let us have some example on this as well. Suppose we have that previous example, we have repeated that set A has 1, 2, 3, B have 4, 5, then the number of elements in A and the number of elements in B, total number of elements in A cross B, and the total number of binary relation will be how much? Now this is what the previous A cross B. So total number of elements in A cross B will be total number binary relation defined on A cross B will be 2 to the power 3 multiplied by 2 to the power 6 gives 64. So we are not in the position to write the whole 64 binary relation here, but just I will present a few among them. Okay, F1 is say empty set. Of course empty set is the subset of every non-empty set, so it is the subset of A cross B. Now F2 is equal to 1 comma 4. This set belongs to A cross B. F3 is also belongs to 2 comma 4 belongs to A cross B, and say R is equal to 1 comma 4, 2 comma 5 belongs to A cross B. Say another G is equal to 1 comma 4, 2 comma 5, 4, 3 comma 5 also belongs to A cross B. So these are the binary relation defined from A to B, and they are among those 64, but I have taken just 4 to 5. Okay, so in similar fashion we can define the rest of the binary relation from A to B. Now if we have just only one set, say 2 comma 3, set A is equal to 2 comma 3, the number of elements in A are 2, the number of elements in A cross A will equal to 2 to the 4, and total binary relation on A cross A will be 2 to the power 2 square. 2 to the power 2 square means 2 to the power 4, and 2 to the power 4 means 16 binary relation will be there. So of course our lad few of them, that is F1 is empty, F2 is equal to F1 again F1, F2 is equal to 2 comma 3, 3 comma 5, 2 and 3 comma 3. Similarly F3 is 2 comma 3, 2 comma 2, etc. Now the next definition is of dependent and independent variables. What is variable? Variable is a quantity which changes itself during some program or circumstances. So in maths equation, variables are the symbols or letters that represent numbers whose values can change. Okay, so variables can either be dependent or independent variables. One depend upon the others. So dependent variable rely on the other variables to find their values. Okay, if you want to find the value of the dependent variable, so definitely we will provide some value to the next variable, other variables, and then we will find the value of the dependent variable. And the independent variables do not rely on other variables to find their values. So to sum it up, an independent variable will change the value of the dependent variable, but the dependent variable cannot change the value of the independent variable, and the value of the dependent variable is determined by the value of the independent variable. Let us take some example on this to make it clear to you. To give you a clear view of independent variable, let us consider this example. Suppose we have a square whose length is equal to x, and it is a square, so all the sides will have the same length, that is x. And we know that the area of the square is length multiplied by length, that is x square. Let us denote this area by y. Okay, so this is what y is equal to x square. You know x square is the area of the square. Now you see that if we increase or decrease the side of a square, say by a unit or 2, then definitely we have change in the area of the square. So what this area, that is the dependent variable, depends upon this independent variable. If we decrease this, say like this, of course the area will become smaller than that one. If we increase it, so the area will be more than the previous original square. Okay, so this y depends upon this x, where x is the length of the side. So if x increase or decrease, definitely there will be a change in the area. Now let us take another example in which we want to try to show you that the independent variable be more than 1. Suppose this, we have a cube here. Okay, this cube have length, width and height, and clearly its volume is defined as length multiplied by width multiplied by height. So here you see that, you can see easily that this volume depends upon more than one variable. So these are what? Independent variable, and the variable which depends upon these, that is the volume, is called the dependent variable. So hope you have get the point of independent and dependent variables. Same is the case, you depend nowadays upon your parents. Okay, so you are what? Dependent, and your parents are independent. Similarly, your parents are what? Depends upon their jobs. Okay, so these are the example of independent dependent variable in daily life. Let's have independent variable, the factor that is varied or manipulated. Okay, we have seen in the previous example that if the independent variable change, it change the dependent variable as well. So the assumed case of the problem is always what? The independent variable. In other words, we say that the subject of the domain is always independent variable, and the variable which depends on the subject of the variable is called dependent variable. Dependent variable, the factor that is measured or observed. Okay, in the previous example you see that y was measured, y was depending upon x. Okay, and similarly v was depending upon the other three variables. The change that is brought about r is affected by the change in the independent variable, as already discussed with you in the previous example. So the assume effect of another variable, and you know that success depends upon the efforts. Okay, as you put your efforts, the success will comes in your future and in your hand. We know that F is directly proportional to A, that is force is directly proportional to the acceleration. And you know this, that this is a relation we can write at m, where m is the mass of a body. Okay, so F is equal to ma. Clearly here A is the subject of the domain, that is F depends upon A. So F is now what? The dependent variable, and A is the independent variable. If we solve like this, that A is equal to F divided by M, then we actually made F as the subject of the domain, and A depends upon F now. So what? F is now independent and A is the dependent variable. So whenever a quantity is the subject of the domain, then it is called independent variable, and the variable which depends upon it is called the dependent variable. Now it's your turn, dears. You have to solve this worksheet and send me back its solution. Also comments me in my channel, and subscribe the channel so that you can receive videos like this. Okay, so see you in the next video.